universe started, or when the universe started, there was a Big Bang. So after that Big Bang, a fraction of a second after that Big Bang, scientists believe that in that tiny fraction of a second, we can answer questions about our universe, and that there's answers in that tiny fraction of a second after the Big Bang. So how do we study something that happened 13.1 billion years ago? So today, with modern technology, scientists have been able to create what they call the Large Hadron Collider. This collider is built in Switzerland, right near the border of France, and it's built underground, and it's made out of 3 rings. This collider is 27 kilometers long. To get perspective of how big that is, if this collider was here in Portland, it would run through Hillsborough, all the way to Battleground, to Troutdale, all the way back to Canby, back to Hillsborough. That's how big this collider is. So what does the collider do? So according to Halpin's 2009 publication of Collider, so the search of the world's smallest particle, he states that we're all made out of matter. You and I are made out of matter, the universe is made out of matter, planets are made out of matter. And in matter is composed of atoms. Atoms have elements that contain electrons, neutrons, and protons. So what the collider does, it takes those protons from that atom, it puts them in this tube, this circular tube, and spins them around the speed of light, all the way until they get to this detector, where they're made to collide. In this collision, within this detector, when 2 protons collide together, different particles come out, what they're called quarks. So each detector, there's 4 of them, and each one does a specific experiment. First, there's a LHC detector. This experiment is run to detect the antimatter and matter from the collision. So when these particles collide, antimatter and matter are created. And this detector's job is to detect how that is created. ALICE detects the ions in the protons. CMS and ATLAS, they're both 2 of a kind. They're both responsible for collecting data on new particles. So according to Brock in the physics of research, he says that currently scientists know that there's asteroids, right? There's asteroids, there's planets, we could see them. There's stars, plenty of stars. So what the collider does is it's trying to explain what holds us all together, what keeps us aligned and prevents us from floating away like little dust in the sky. What is that matter that keeps us all together? Scientists currently, according to Baggett in the Higgs 2012 publications of the Intervention Discovery of the God Particle, they're saying that dark matter is responsible for holding us together, holding the planet and giving us mass. So to explain a little bit about what dark matter is, it's the space between us. Dark matter is between you and I right now. Dark matter is between the sun and Earth right now. To get a visual of it, imagine a jar of jelly beans. And each colored jelly bean represents a planet or a star. Dark matter will be the black jelly bean holding it all together. This is very easy to visualize how everything's being held in place. But how do we study a particle that we can't see, a particle that we can't touch? We have to take it back to the basic laws of energy, the conservation of energy. The basic law states that when the energy can't be created or destroyed. In physics, when I touch this camera, my energy is not created or destroyed. It simply moves the camera, transfer. But what we're learning is that when we're colliding these particles, we're seeing that this law is being broken constantly by antimatter. And the reason why is because antimatter has an evil twin, or has a good twin. And that good twin is matter. And the evil twin of matter is antimatter. So what happens when these 2 protons come, they collide in the detector, antimatter and matter are created, but what happens is when they meet, they both annihilate each other, which again breaks that law, because energy can't be created or destroyed, but antimatter and matter do just that. So there's got to be an explanation for all this. So the Large Hadron Collider does just that. It grabs matter's energy it puts it into this tube, spins it around, collides it, and makes antimatter and matter in equal amounts. The same amounts that were present that fraction of a second after the Big Bang. So we are able to study over and over what are those particles that make all of us and hold us together, to get a better understanding of how our universe came to be. How did that expansion come out, and why it doesn't go the other way? What's keeping us all over there, held together? The biggest theory right now, what the collider is out to prove, is called the Higgs boson. This particle is what scientists believe that dark matter is made out of. It's this particle called the Higgs boson. So the way that they explain it is that this particle is all around us. It's invisible. It's what's holding us together. If this picture represents an atom, the blue and red part, and the little sparks represent electrons, the Higgs boson would be that little cloudy guy that is all around us, holding us together. But we're not able to see it. But the collider is able to detect it when the two particles collide. Because that 10th of a second after the collision, that's the only time when it's present. So as the collider, as we're learning, the Higgs boson, what's making it so difficult to find is that each line represents a particle, a different particle. So when they collide these particles, they have to go and analyze all this data and try to pick up through and to see if it exists. If it does exist, that's great for science. We could move on, we could explore more about this technology and improve it for our own better use. If it doesn't exist, back to the drawing board. Then we have to go and find a new physics to explain what holds our Earth together. And from all this research, technology, and colliding, great advances in technology have happened. We've been able to have X-rays at airports because of what the collider has done. That we have learned that there's 12 new particles because from the experiments that they've been running. So at the end of the day, when this experiment is over and they've got the information that they need, all this technology and all this information that we've learned is going to go to make technology for Earth, to make it a greener, better, cleaner Earth here today. And that's what the collider does for us here.
What's this time?
7:51.
Now, Diedrich, I only caught 3 sources, but I think you might have more.
Yeah, I did 5. I think I went down the list. I was trying to get that 6th one in.
That's good enough for me.